So the notes look like this for section 5.3. Okay. Like I said, we're dealing with polynomials and all the different characteristics. And we're going to start with some definitions. These are some terms that you've heard me kind of throw around, but they're also going to be helpful for us when we start to categorize polynomials the way that we need to. All right. A constant is a term used a lot in this class, or I've used pretty frequently. How would you categorize a constant? If I say this is the constant term, a lot of times it's just what? Just a regular number, right? Good. So our definition of a constant, just any number. All right. And that's any real number. We could have 5, -2, 1/2, 3/4. Any real number that we can have in our polynomial expression is just a constant term. Okay. Next term we have is a monomial. What does that prefix mono mean? 1. Test everybody's English skills today. Mono means 1. So a monomial is just one term. It's going to be a number and a variable and the product of those things. Okay. So an example of a monomial, just that one term, we could say it would be x, 5x. Could be multiple variables, but still all one term, just a product of a number, variables, or multiple variables. Okay. So 2xy is a monomial too. It's just that singular term. Okay. Any questions so far? Coefficient, we use that a lot often, especially when we used synthetic division. We talked about having to find coefficients. How would you describe a coefficient? Right, it's the number in front of that variable, in front of that singular term. So we'll say the number in front of a term is what's called our coefficient. So if I look at like 2x squared y, what would be my coefficient? 2. And on your homework tonight, you're going to have to list out what the leading coefficient of a polynomial is going to be. So tonight's homework is a lot of just categorizing, which we're going to get to a little bit later on today. But just so you're aware, what a coefficient is, obviously it's that number that's going to be in front. And you're going to be asked to kind of find that later on. A polynomial, which is the center of our chapter, is a monomial. Oh, excuse me. A monomial or the sum of monomials. So it could be that one singular term, or a lot of times we'll see the sum of multiple terms. So like 3x cubed plus 4x plus 1 is a polynomial. 7x to the 4th plus 3x squared plus 2x plus 3. That would be a polynomial as well. It's the sum of those terms. Question? For polynomial? Yeah. A monomial or the sum of monomials? I know it's kind of tight there written, but okay. The degree of a monomial, so we're talking about just one variable in this case. A lot of times degree, what's another word for degree? We're talking about it in math terms. If I say it's to this degree, like an exponent, exactly. So it's going to be the exponent of the singular variable. Right? So if I have 2x to the fifth, that's my monomial. What's the degree of that monomial? What's that? To the fifth, right? So this has degree 5. If I say 7x, that has degree what? Degree of 1. So when we're dealing with just one term, we're talking about the degree of that monomial, one term. It's whatever the exponent is of just that singular variable. How this differs when we talk about a polynomial, because we have multiple terms, it's going to be the highest degree of all the terms. And it might be useful for you to kind of underline all or something like that. Because if I'm looking at, for example, 3x to the fifth plus 7x to the seventh plus 2x minus 5, right? That's a polynomial. It's the sum of those monomials. It's the sum of all those terms. And if we're looking at the degree, it's the highest degree of all the terms. So what we want to look at, and this is another thing that's going to come up on your homework tonight, is what's the degree of this polynomial? You're going to look for the highest exponent. Well, out of that polynomial, what's the highest exponent you see? 7. So this is degree 7. Okay. Any questions so far? We have a constant, just a number. Monomial is one term, product of a number and a variable. Coefficient's the number in front. Polynomial, sum of monomials. Degree of a monomial, just that exponent. Degree of a polynomial, what the highest exponent is out of all of your terms. Okay. We want to be able to write polynomials in what's called standard form. And we've kind of already done this with a lot of our answers when we were simplifying and going through our operations. But standard form essentially is all the terms of a polynomial arranged in descending order. Listed from highest exponent to lowest exponent. So standard form is listing the terms of a polynomial in descending order from highest exponent to lowest exponent. Okay. This is going to help us with categorizing the way that we write something in standard form. The first thing we want to do is make sure we can simplify. So if there's any common terms or like terms, we want to combine them. So we have the correct amount of terms, and then we're going to write it in order from ascending to descending order from highest to lowest exponent. So for example, in number 1, the first thing I want to check to make sure is that I don't have any terms that I can combine. Okay. Well, I don't here, right? I have 3x, 9x squared, and 5. I'm not going to be able to combine any of them. So I just go ahead and I write this from highest exponent, the 9x squared, then comes the 3x, then the 5. So to lowest exponent. Okay. In number 2, notice that I can combine terms before I start writing my polynomial in standard form. So I have this negative 6x squared plus 10x squared. So now my terms are 4x positive 4x squared from combining those terms, x to the 4th and negative 12. So my question for you is, how would you write this in standard form? So after you combine terms, how would you write this in standard form? Good. So x to the fourth, that highest exponent, then comes the 4x squared, then the 4x, then minus 12. All right, so this here is your answer in standard form. Okay. Any questions about those first two examples? Somebody tell me what I would need to do to start number 3. Combine the 5 and the negative 2, right? So now I have 2x, negative 2x squared plus x cubed. 5 minus 2 is going to give me a positive 3. How would I put these terms in standard form? Maybe somebody from home help me out with this. What would be the standard form of this polynomial expression given all of these terms?
X to the third minus 2x squared plus 3.
Good. X to the third minus 2x squared plus 3. Follow-up question, something that, like I said, you're going to see on your homework. What's the degree of this polynomial? So using our definition from before, 3. Good. Right? It's whatever that highest exponent is. So this is of degree 3. And what's the leading coefficient of that polynomial? What's in front of that x cubed? A 1, right? Another question that you might be asked is what's the leading coefficient of this polynomial expression? Okay. We're going to skip over number 4. Does anybody have any questions about those examples? Pretty easy stuff, right? You combine like terms, list it from highest exponent to lowest exponent. Okay. Now we have a good understanding of standard form, so how we're going to write our polynomials and some of the terms that we might come across. Now we're going to get into the classifying aspect of polynomials. So ways for us to kind of say, okay, given this expression, I can name it by degree and I can name it by the number of terms. All right, this is going to be important for us because certain polynomials, based off of how we can categorize them, have certain characteristics. All right. If it has degree 0, so there's 2 ways that we can do this. We can classify it by degree and by terms. We're going to start with degrees. If it has degree 0, remember, anything of degree 0, if it's x to the 0 power, that's just 1, right? Anything to the 0 power is 1. Well, if there is no variable involved, and it has degree 0, this is just a constant. So an example would just be 5, right? A polynomial, it's just a constant. It's just any number. We talked about that on the first page. If it is of the first degree, so for example, if I have like the polynomial x plus 4, right? The highest exponent I see is to the first power. Think back to maybe a previous math class. What do you think the graph of x plus 4 is going to be? Okay, but how would you? Okay, what was that last word you said? It's linear. Good, right? If you were to graph that, it would be a line. So the way that we classify something with a degree of 1 is linear. If I have a polynomial, for example, 4x squared plus 1, it has that degree 2. We talked about this in the last chapter. So it might have a parabola shape, but it's called something different that starts with a Q. Quadratic. Good. So if it is of the second degree, it is a quadratic. If it's of the third degree, what do you think that's called? Good. Yeah. Cubic. So if we have like 3x cubed plus 2x plus 4, The highest degree there is the third degree, which is a cubic function. And the last ones that are kind of tougher, quartic and quintic. So quartic, like 2x to the fourth, the highest power is 4. And then quintic, like negative x to the fifth minus x cubed minus 1. The highest power there is 5. So when we go to categorize, what we're going to be able to do is say, okay, well, this is a linear, and then we're going to use a word to describe the number of terms. Or maybe it's a cubic this, or a quintic this. Depends on what the highest term is of your polynomial. Okay? We can also classify it by the number of terms. So that's what that second word is going to be when we classify it. So if it is one term, we talked about this on the first page, what would one term be? So that's if it has degree 1, but so that's if it has degree 0, but I'm saying just one term in general. Starts with an M. Monomial. Good. So one term, a monomial. So like if we have just like 3x squared, it's one singular term, it's a monomial. So as we're going through, it's a monomial, it has degree 2, so this would be a quadratic monomial. That's how you categorize, all right? What do we think it has, what it's called, excuse me, if it's of degree 2? What's that prefix for 2? So mono, and then I said we'll see how good we are at prefixes. What's that? Not die.
Bi.
Bi. Good. So a binomial, right? 2. So it has 2 terms, like 2x cubed plus 5. So with that specific example there, it has degree 3, so it's cubic. It has 2 terms. It's a cubic binomial. Ways to categorize. Hopefully we know this one. What's the prefix for 3? Tri, right? Good. So we have a trinomial. And then anything 4 or greater is literally just called a polynomial of 4 terms. There's no fancy word for that, okay? So if it had 6 terms, polynomial of 6 terms, okay? Any questions about the different names that we have to categorize? Okay. The first thing that we're going to do, very similar to standard form, is we're going to do a couple examples here. We're going to simplify our expression first. So we're going to combine any terms, because if we forget to do that, we might think that there's more terms than we actually have, and then we're going to categorize it incorrectly. All right. So we'll combine terms to start, then we'll try and classify it based off its degree and number of terms that we have. So for example, I'll kind of just do this first one on my own, and I'll see if I can keep the charts here for us so it's a little bit easier. The first one, I have 7x plus 3x plus 5. Well, I should notice that I can combine the 7x and the 3x. And then when I write it in standard form, I have 10x plus 5. Okay. So now what I'm going to do is try and classify that by degree and the number of terms. The highest degree I have here is of first degree, right? That x to the first power. So I know it's going to be linear because that's my first power degree. And it has 2 terms. Well, if it has 2 terms, then it is a linear binomial. And the reason that we're doing this, the reason this is effective is because if I know it's linear, if I can see a polynomial and look at that and then describe it in a certain way or classify it, I know it's going to be a line, but I also know that there's two terms, so it's going to be shifted in some way as well. So that's a reason why it's important to understand what we're dealing with for each of these polynomials. Okay. Example 2. Somebody help me write example 2 in standard form. Good. 2m squared plus 7m minus 3. So how would you categorize this? What's the highest degree? Maybe somebody from home help me out with this one. What's the highest degree that I see here for this expression?
To the power of 2, is that the degree?
Right, to the second degree. So if it's to the second degree, what's that going to be called? Or how would I categorize this? What's that? So it's quadratic. And how many terms does it have? 3. So trinomial. Good. A quadratic trinomial. Again, I classify it, and without even necessarily putting anything on paper or graphing it, I'm able to determine, all right, well, it's quadratic. We saw quadratic equations and formulas and stuff like that in the previous chapter. And we also saw graphs, right? It had that U shape. It was a parabola. So it's helpful to kind of understand this. And also we're going to know it's going to shift in some way because it's a trinomial. Okay. Next one. Let's put this in standard form. X to the fourth minus x cubed plus x. If it is the fourth power, how would you categorize this based off of its degree? Quartic. And how many terms does it have? 3, so it's a trinomial. Good. We're getting the hang of this. Pretty easy stuff. Now, the graph of an x to the fourth is going to look a little bit different, right? Kind of depends on some of the terms after it. But again, it's going to help us understand where we're headed with that. All right. Let's do a couple more. 7x cubed. How would you categorize that? A cubic monomial. Right? Cubic because it's to the third power. Monomial because it has one term. Okay. We'll do this next example, and then we'll talk about the assignment for tonight as well, just to kind of give you guys a heads up on what the rest of the week's going to look like. So number 5, how about somebody from home help me out with this one? Number 5, if you were to describe this, it's a negative x to the fifth plus 2x. If you were to describe this using one of our words for just the degree, how would you classify it?
Quintic.
Binomial.
Quintic, and then I heard someone else say binomial. Great. So it's quintic, because that's the way that we categorize something to the fifth power, and then binomial, because it has 2 terms. Good. Any questions about some of the terms we discussed today, putting something in standard form, or ways to categorize our different polynomial expressions? Anything at all? Okay. So that's just the first part of section 5.3. So I'm going to stop sharing for just 1 second here. And I'm going to just want to make one quick change to something. Okay, so your homework for tonight, I'm just going to share my screen again. Your homework for tonight is on page 326, numbers 13 through 21 odd. Okay, so 326, 13 through 21 odd. If you take a look at this, what we want to do is state the degree and leading coefficient of each of the polynomials in 13 through 21. So the first thing you're going to do is make sure that it's simplified, right? If you can combine like terms, make sure you do that. Make sure that you write it in standard form. Like I can already tell some of them are written in standard form and some of them are not. So put it in order. And then from there, I want you to do three things. So the directions there say state the degree, which we should be able to do. State the leading coefficient. So whatever that highest term is, with that highest exponent, write what the coefficient is. And then the last thing I want you to do is classify it. All right. So for example, in number one, I have three terms. So it is a trinomial. And it's to the sixth power. Well, that would just be a power of six, right? We didn't really talk about that. So power of six trinomial. Okay. In example 18 over here, I have four terms. So it's a polynomial of four terms. I know if I put that in order in 18, the highest power is 5. So it's a quintic polynomial of four terms. And then you would say the leading coefficient is 3. So that's what I want to see for each of those questions there. You have 1, 2, 3, 4, 5 of them. So you're going to put it in standard form, write the leading coefficient, the degree, and then also classify it. Okay. Any questions about what that assignment is? Good. So next, that was gonna be my next thing. I'll explain it in a second. But does anybody have any questions about just that assignment? Okay. The other piece of our class for tomorrow. So obviously tomorrow is asynchronous. Either later tonight or tomorrow morning, I will have a video on the second half of this section. So 5.3 day 2. All right. I will do a video lesson, and my expectation is that you continue on with the assignment that's going to be due. All right. So actually, if we take a look at tomorrow's folder, give me 1 second to pull that up. We take a look at tomorrow's folder. So Friday 3/12. At the top is the notes. It's out of the same note packet that we're working out of today. So today we did pages 1 and 2. Tomorrow we're going to be doing pages 4 and 5. We're going to skip page 3 for right now. The homework assignment is there. That would be your asynchronous work. And I would have the video kind of in the middle there too, based off of what you need to do for those problems. Okay. The lesson itself isn't overly difficult. It's very similar to kind of understanding some characteristics of a polynomial. And we're going to dive deeper into what a graph would look like based off of what kind of polynomial we'll have and kind of the characteristics of that. Okay. So really good question. Make sure that you are in tune. I'll probably put an announcement out later today as well, in tune to what you need to do and what you need to accomplish for tonight, tomorrow, and the weekend. Okay. Because obviously tomorrow is asynchronous. Any other questions about the assignment for tonight or the expectation for tomorrow?